I'm really delighted to welcome you all, and there are hundreds of you I know watching this, this presentation, to a very special instalment of the Royal Academy of Engineering's Innovation in a Crisis series, which is bringing us together to celebrate and find out more about the winners of the President's Special Awards for Pandemic Service. You've just seen them in the video, and I'll be speaking to some of them a bit later on, and there will be an opportunity for you all to pose questions to them as well. Now, since the onset of the pandemic, I'm sure you've been as proud as I have to observe the Academy using its expertise and networks both nationally and internationally to help solve critical challenges and to assist the public health response. Testing and vaccines, field hospitals and PPE, engineering has been key to so many aspects of the response. This Innovation in a Crisis series and the President's Special Awards for Pandemic Service are also part of the Academy's response to the COVID-19 pandemic, shining a light on and celebrating these engineering efforts. My first set of guests will set the scene for us by telling us more about these particular activities and some of the stories that inspired them. So I'm delighted to introduce you to your first speakers for today's event. President of the Academy and Principal and Vice-Chancellor of the University of Strathclyde, Professor Sir Jim McDonald, and Chair of the Academy of Engineering Awards Committee and Professor of Chemical Engineering at Heriot-Watt University, Professor Raffaella Ocone. And Jim is going to open by telling us a little bit more about the Academy and the wider engineering community and how they've responded to the crisis. So Jim, over to you.
Thank you very much, Karen, and a very good afternoon to our fellows on the call, to our colleagues and partners, and very importantly to our fantastic award winners. Why are we here today? Well, it's become very clear over recent months that the COVID-19 pandemic, the biggest public health crisis of our time, has called for rapid innovation to protect lives and livelihoods across the globe. And there has never been a more urgent need for engineering expertise to inform public debate and to provide workable solutions for all of our shared challenges. In March, as a very immediate response and desire to help, the Academy issued a call for engineers who could address the problems and challenges arising from the pandemic. Wonderfully, the response that we saw, it was inspiring to receive over 500 responses in a matter of days from engineers from across the specialities, from various career stages, offering innovative ideas, advice and expertise, as well as access to manufacturing capability and other facilities. The sheer breadth of their contributions and the critical role that they've played in managing the impact that of the pandemic is absolutely astonishing. As you've heard from Karen, including ventilators through to rapid hospital building, from modelling space planning and supply networks to developing anti-infection coatings for surfaces, engineers have indeed been in the vanguard of the response. And of course, the Academy has supported this response in every way we can. The National Engineering Policy Centre, which the Academy leads, has fed engineering advice and expertise directly into government. We have run online webinars for entrepreneurs to help them manage the impact the pandemic may be having on their businesses. And we launched the Project CARE to mobilise African entrepreneurs from our international programmes to address the consequences and impacts of COVID-19 in their particular communities. And we were also able to bring together an international group of experts to share knowledge and best practice on how different countries were responding. The Innovation in a Crisis series was another part of our response. The series was launched with the intention of capturing the stories and experiences of those working at pace and at times under many constraints, and trying to capture any lessons that we can take from them. And it's been great to learn from these winners' experience as part of that work, as well, of course, as celebrating their fantastic achievements.
Yeah, I agree, Jim. Thank you very much. And Raffaella, you had the difficult job of chairing the judging of the Pandemic Service Awards. Can you tell us a little bit about that, please?
Sure. Thank you, Karen. Yes, it was a difficult job. However, I think that for me, it was a very pleasant, very rewarding job. We have seen how engineering skills have really made such a difference, have been so vitally important throughout the pandemics. And indeed, these are the skills that really we wanted to reward, and these are the skills that have made a difference in our lives. So essentially, in order to recognize the contribution that the engineering community has made, helping the society address the pandemic challenges, we created the President's Special Awards for Pandemic Service. And we want to recognize really all the incredible work that the engineering community, including people and teams, of course, have done at these very difficult times, and have been able to deliver incredible solutions that really a great impact. Now, these are really examples, I think, that how engineers really, and engineering is at the service of society. The awards are very diverse, and I think that we have seen some of them already. We will see some others today, and they have been going from keep essential services, make sure that infrastructure were working effectively, and also work directly helping protect the NHS. We have 19 awards. Of course, I mean, we had many submissions, many nominations, but we awarded 19 awards, and this went to teams, organizations, individuals, and it was across all the technical specialties, disciplines, and career stage within the UK engineering community. And later this year, there will be the winners will receive a nice silver medals, which has been commissioned specifically for the purpose. And I would like, I'm going to conclude just saying the fact that, you know, I really enjoyed this judging the submissions, because I think that, you know, I have seen such a variety of nominations, as well as so many diverse teams that play so much a diverse role in stimulating innovations and creative thinking, really. And many of the winners really show that it's also important to collaborate, to work in an international arena. And I think that, you know, we really have seen incredible impact to help address the most pressing global challenges with this award. So yes, I will stop here.
Thank you, Raffaella, and I really appreciate your enthusiasm for judging the awards and the care and attention you gave to the detail of making sure that we had the absolute best people, you know, and the best projects receiving these awards. And, you know, I'm also the chair of the Academy's Research Committee, and the Academy funds excellent researchers at every stage of their careers. And what I've enjoyed seeing is actually some of a number of those researchers that we've supported in the past have been amongst the names on this list of winners. So it's really lovely to see those people progressing through their careers and continuing to be successful in the various projects that they work on. So I want to hand back over to Jim now, because I think we've got a very special video message which I'd like him to introduce for us before we get back into our discussion. So over to you, Jim.
Thanks, Karen, and indeed we have a great treat here. As many folk will understand, Her Royal Highness, the Princess Royal, is our Royal Fellow. She has long been an enthusiastic and committed supporter of the Academy, and most importantly, an advocate for the contribution engineers make to society. Consequently, when we established these awards, we were delighted that she wanted to congratulate all of the winners personally. And here is what she had to say.
Celebrating engineering excellence has always been central to the work of the Royal Academy of Engineering. And I'm delighted to add my own words of congratulations to all the talented individuals who are receiving these awards for their innovative and tireless work to address and overcome so many of the challenges society has faced during the COVID-19 pandemic. The breadth of their contributions is astonishing, from ventilators to rapid hospital building, from modelling supply networks to developing new means of vaccine production. What engineers do, whatever their specialism, is to understand and help solve problems. The diversity of the teams involved is noticeable and shows how bringing together people with different perspectives, whether that is their education, experience, or identity, increases innovation and creativity and results in better solutions. I hope their successes will help to inspire many more young people from all backgrounds to consider engineering and the exciting, varied and rewarding careers it offers. These awards show that engineers make a real difference in the world, and we need more of them to meet demand. My congratulations to all these award winners and to engineers everywhere who make such a positive contribution to society. Thank you.
Right, well, thank you very much, Your Royal Highness. It feels like she's in the room with us, doesn't it? And it's great to have this royal support. So, reflecting on what's been said so far, I think I'd like to ask a few questions to Jim and Raffaella, really, to find out more about the process and your thoughts. So I guess, Raffaella, first of all, I have to ask this. You know, so many incredible examples of engineering in response to the pandemic. So what approach did you take to narrowing it down to choose the winners?
Well, Karen, it was a very difficult task. We received a large number of nominations. All of them were of very high caliber. We based our decisions on the engineering excellence of each project and what the contribution to tackle COVID in a very rapid way in order to assist the public health response. So this was essentially our criteria. We were very delighted to see such a diversity of nominations. So in terms of, like I said, diversity of engineering achievements, diversity of teams background, career stage. And with our awards, we really wanted to recognize all the spectrum of engineering excellence in the UK and all the contributions. So I think that, you know, this was essentially what we did. And I would like also to recognize all the contributions of the committee, the award committee. I think my colleagues were absolutely astonishingly in the way they respond so fastly to the review process. We have to review many nominations in a short time, and also I would like to thank all the participants, because, like I said, it was a difficult task for us to come down with the 19 winners. All the submissions were of very high caliber.
Yeah, thank you, Raffaella. And I think, you know, for me, we always know that engineers really, you know, we always roll our sleeves up in a crisis, don't we? And we always, you know, come to the fore with solutions, whatever it is. But particularly in the pandemic, I see examples all over the place that of really exciting work that engineers have been doing. We've been putting our thinking caps on and we've been trying to solve problems. And it's a real joy that the Academy was able to give these awards. And also we were able to really react very quickly, as you said, Raffaella, to muster a team to judge the awards and get the awards out quickly, because the speed of the Academy's response here is important. And we can talk about what happens next year. But Jim, as president of the Academy, and you know, and the Academy is the leading body for engineers in our country, you know, we all know that the pandemic is far from over. So what role do you think engineers can play in the months ahead?
Thank you, Karen. And just as I do that, may I just reflect along with you my thanks to Raffaella and the panel for having done an outstanding job in bringing forward these 19 prize winners. But to your question directly, Karen, what's been clear to me, and it's been encouraging and inspiring, that over the past 4 or 5 months, albeit under very challenging circumstances, I think society and the policymakers, as well as other disciplines, are recognising the role that engineers can play, and indeed have been playing in fighting the pandemic, alongside, of course, and respectfully, of the medical and healthcare professionals, epidemiologists, virologists, scientists, and public health experts. It's been tripping off the tongue that the government has been following science, and that's right and proper. But I think increasingly I've noticed the debate and the dialogue and the recognition of engineering as a key part of the solutions. Around the health debate about, you know, dealing with the economic impacts, about creating new technologies, you know, manufacturing devices, thinking about systems, and that's something that engineers do, I think, best of all. That systems approach to understanding interdependencies, some of the complexities, and I have to say I'm very proud and inspired by everything that I've seen in the prize winners today. But our government's chief scientist, Sir Patrick Vallance, has also become a wonderful advocate for the power of engineering and what engineering can do, particularly under these circumstances. And only last month, Patrick made 2 direct references to the Royal Academy of Engineering whilst he was giving evidence to the House of Lords. And I think that speaks volumes of the growing understanding, and what follows that is respect. So in many ways, I think the engineers must continue to politely but independently and based on evidence and knowledge affect policy. We have to work with our colleagues in government and industry, but particularly the policymakers. Our government is clearly remaining in a very challenging, fast-moving set of circumstances, but that trusted relationship with the Royal Academy of Engineering, the trusted relationship with engineering as a community, will allow us to have more of an influence on how we shape the country's response. But in doing that, we also have to, as you've said, Karen, continue to look for innovative solutions, whether it's around safe public transport, whether it's getting those vaccines manufactured to the right quality with the right industrial collaborations. And of course, very importantly, we talk about the health impacts, but we really need to work hard to help this economy recover. And it's very encouraging for me to hear the government speaking so regularly and consistently, and as embedded in the new UK R&D roadmap, engineering and technology is the heart of our recovery, and it's really the future for this nation. And the Royal Academy and its community of fellows and their partners were going to be fundamental to delivering that future.
And of course, we have to think about the fundamental skills that are needed, don't we, Jim? And one thing I've been reflecting on recently is that, you know, obviously, and quite rightly, the medical professions and the healthcare professions have had a huge publicity, if you like. You know, their work has been really brought to the fore, and you know, the public are more aware and more appreciative of what the medical and healthcare professions do. And as a result of this, I'm sure you've seen, as well as we have in the universities, a real massive increase in the people who are interested in taking up these professions. I haven't observed that effect on engineering yet. So how do you think we can get over that message, you know, of the underpinning work and the advances and the innovation that we as engineers do to encourage more young people to consider engineering in the same light as medicine and healthcare and so on?
Indeed, I make a comment, and Raffaella will have a view on this as well. I think it's a great question, and what a great challenge. And I would say for the Academy, an opportunity. And what a great vehicle we've got in the This is Engineering programme. You know, over the past few years, we've been having a fantastic impact on informing particularly young people, not always young people, but particularly young people, about the value of engineering. Whether it's in dealing with, you know, looking after climate change and the global impacts of the warming of the planet. But here we have now is deep evidence, here in the UK in particular, but of course there are international references where engineering has made a major impact. You know, the social conscious that young people have is absolutely acute. I think increasing year on year. That's absolutely evident when we talk about net zero and decarbonisation and renewable energy and, you know, getting electrification into transport. Here we have now a most meaningful means by which we can say to young people that are selecting their careers, you know, engineers, help healthcare, help medical practitioners, help save lives, you know, make the nation a safe place to live and thrive in. And I am pretty sure that in this coming years, This is Engineering programme, there'll be many references to the wonderful things, not least of which those that we're going to see in the prize winners today, that have made such a difference to people's well-being and the ability to deal with the pandemic. So I'm actually very optimistic, Karen, that you know, this is an opportunity for us to showcase engineering, and this idea that Raffaella has also talked about engineering at the service of society. There's no better place in which we can demonstrate that in the way that we've dealt with the pandemic over the recent months.
Yeah, thanks, Jim. Raffaella, do you want to pick up on those thoughts of Jim's, and perhaps, you know, if you highlight any stories amongst the winners that particularly inspired you that we can use as an example to young people?
Sure. Well, I think that, you know, again, Jim very well elucidated what we should do to encourage more people into engineering. And I think the social aspect of engineering is something we should stress and we should really encourage, like Jim rightly said. And also, I think that sometimes, you know, we have to relate it to personal stories and to things that can encourage people to do engineering. And in fact, I think that, you know, there were some examples when among our winners that there were very personal stories. Like, for instance, you know, one of those really, which really attracted my attention was the one very simple device, the handy hook. And, you know, it's just something, a little device that avoids people to touch directly surfaces, so to come in contact with virus. And it's not, I think the personal touch, the fact that the engineer behind that device was thinking about his mother working in a COVID ward in an hospital in Essex, and tried to help her by not coming in contact with all the surfaces which could be infected. And I thought that, you know, that personal touch coming out with an invention just for his mother resulted in something exceptional. And in fact, I think, you know, it was also the social aspect of involving two of his colleagues and working for 2 days to using all their personal material for 3D printing with their 3D printers, 400 hooks that were distributed among NHS staff free of charge, of course, and then everything which followed in terms of donations, in terms of crowdfunding and so on. So I think this aspect will be very attractive for young people to come into engineering. And, you know, and also let's not forget, you know, there is also an aspect about education and about the role that students do. And the students are the best ambassadors, I believe, for what we do. And, you know, there is another winner who produced this recyclable face shield. And of course, I mean, you know, the environment is one of our concerns. We have seen so much, well, so many masks actually in the street these days. And to come out with something that protect us, but also is friendly within for the environment is great. And I mean, this idea came out just from a task which was given to students, because the students were coming to the university, and then they were given a task of designing something using cardboard and laser cutters. So Dr. Robotham, who is behind the idea, looking at what the students were trying to do, came out with the idea of creating a recycled face shield. So I think that, you know, beautiful examples that we have to be able to communicate and to make young people to relate to and to make them aware of how engineering is really at the core of society, really.
Yeah, thank you, Raffaella. They are indeed beautiful examples, and they're both driven by passion, aren't they? They're both driven by passion to improve a situation. You know, I think that's fantastic. International collaboration has been very important as well, because the pandemic, you know, isn't limited to one country. And so, why do you think international collaboration has helped or been important during the pandemic?
I mean, it's clear to me, Karen, that this idea of not just sharing facilities, of course, that, you know, no one place, no one institution, no one company has everything that they need, but the idea of sharing resources is fundamental. And we're talking about a grand scale, as we can see here in the analogy of the pursuit of a successful vaccine that's been properly tested and made safe before it's administered. That's required a multinational, you know, multidisciplinary approach, and that the same's been true for engineering. But of course, international collaboration is a natural follow-on from what we've witnessed. I would like to give a note here where we've seen a great example of that in one of the awards that we're awarding today, and that's the Ventilator Challenge UK, where through this approach to collaboration, the definition of common purpose, we've brought together 33 UK engineering businesses, large and small, from aerospace, automotive, from medical sensors, a lot of that underpinned by academic excellence. So for me, what's inspirational is that, in a magic word, which is easy to say, sometimes hard to define, leadership. Leadership in having the courage to step up, form consortia, share ideas, go beyond the normal institutional boundaries that sometimes inhibit collaboration, and take the very positive lessons of what we've witnessed here. And as many of us know, whether we're academics or colleagues from the industrial sectors, collaboration is fundamental. We've got the phenomenon of globalization. We've got this need for, rapid innovation. And for me, as well as internationalization, bringing a whole range of new ideas and thoughts and perspectives, what a driver for innovation. I think those people that study innovation systems and methods will tell you, having that diverse and inclusive approach to creating teams that are coming up with new ideas, very exciting, but you need those different perspectives. So international collaboration is great, because for big challenges, you need a lot of investment to make things happen, and that's best shared across multiple private and public sector partners. But the multidisciplinarity, I think, is absolutely key. And I think the lessons that we've learned, not least of which from things like the Ventilator Challenge UK, but what we've seen in other aspects, I think will be a driver and could be a model for us to build on going forward.
Yeah, I definitely agree with you. And I think that, the sharing of ideas is so critical, isn't it? And in engineering, we're used to sharing ideas. We're used to working in teams. But I think even more so when you come to this kind of rapid COVID situation and the innovation that's needed there. I think we'll need to get onto we could talk all afternoon, couldn't we? But we'll need to get onto the winners soon. But I just finally, do either of you think that the pandemic will change the way we do engineering?
Raffaella?
Personally, I think so. I think that, we will see new jobs and we will see probably new challenges to train our engineers. And I think that, we will need engineers that have much more a social attitude towards their work, and much more, I think, the aspect of interacting with other people, multidisciplinary work, which is core, like Jim said. And I think that this is what we will see, and like the way we react to the new jobs and the way we have to do new way of public transport, new way of social distancing, and so on. I think that will change completely the way we will do engineering in the future, and also what we will see in engineering contributions for the years to come.
Yeah. And if I may say, Karen, and it's a flagship set of contributions that the Academy makes to thinking, not least of which in the policy sector. But again, let me just reiterate what engineers are good at, which is, he says, most things, of course. But when we come to what else we might promulgate from this experience, and that systems approach to solving major problems. And as you say earlier on, Karen, we're natural problem solvers. I think we're natural collaborators, and we like to share ideas. But I think we now need to celebrate those things that we take for granted are not fully understood, beyond the engineering profession at times. And I think using the platform for understanding systems approaches to deriving solutions and finding, creative ways to collaborate and innovate is great. So again, I'm a very hopeful, in fact, I'm very optimistic that systems approach to problem solutions with big, gnarly problems that the government have to face, and indeed industry has to face. I think that will be a distinguishing contribution that both the Academy and the engineering profession at large will offer in the coming years, given the experience and the reputation that we've built up over recent months.
Yeah, well, thank you, Jim, and thank you, Raffaella, for taking the time to participate and for sharing your really inspirational thoughts with us all. So now I'd like to move on to the second part of this event, the panel discussion with some of the award winners. We couldn't have all 19 on a panel, so we've a small selection of awardees from across the breadth of the projects. And for those of you who've have seen the previous webinars, this panel is in the same format as the other webinars. And just for those of you who haven't seen them, they're all available on the Academy's website. So I'd urge you to have a look at those. So we'll begin with a brief introduction from each of the panelists, followed by questions which I will pose to each of them in turn. And from the audience, I know that you will have loads of questions. So if you want to ask a question, I will try and pick out any of the questions that are relevant. So if you click on the question and answer feature on your screen, located towards the bottom of the screen, and type your question into the open field. There's also a feature which allows you to upvote questions posed by other delegates. So, it is a difficult job for a chair to see all these questions at once and to try and get the most pertinent ones, but I'll do my best, so bear with me. And we'll cover as many questions as possible, time permitting. So without further ado, I'll introduce you to today's speakers. There's three speakers. We have Dr. Tashiv Ramsander of Cambridge Aerothermal for the Open Ventilator System Initiative. We have Professor Zhanfeng Xu from the University of Oxford for the Oxford Rapid Test for COVID-19. Shui, that should be. And we have Dr. Lydia Lyroudia from the University of Exeter for SUAS for COVID, SUAD Epidemiology for Early Warning and Management. So I'd like to go over to the three of them in turn to briefly introduce themselves for around 3 minutes with a brief summary of their projects and to give the audience time to think of some questions. So Tashiv, over to you first.
Good afternoon to you, Karen, and good afternoon to you all. I am Tashiv Ramsander, Director at Cambridge Aerothermal and the Engineering Lead at the Open Ventilator System Initiative, OVSI. OVSI is an initiative that has formed in response to the COVID-19 pandemic with the aim of developing an open source ventilator for manufacture in low to middle income countries. The OVSI team was initially founded by a small number of companies within the Cambridge cluster and members within the University of Cambridge, and has since grown rapidly, comprising of over 30 companies and institutions in more than 5 countries, with our manufacturing partner in South Africa, DeFi Appliances, being the largest white goods manufacturer in Southern Africa. By being centered at the Whittle Laboratory at the University of Cambridge, we have adopted the Whittle's rapid technology development process, which is normally used in the aerospace and power generation sectors. Coupling this with continuous feedback from our embedded clinicians and expertise from within the Cambridge cluster, we have achieved the development of a completely new ventilator in a matter of weeks rather than years. Absolutely integral to the project is Dr. Antonio Damaro, working endlessly to ensure the strong collaboration between the African and UK partners, which manifests itself in all aspects of the project, from idea conception to design and manufacturing. The OVSI ventilator is an ultra-flexible, robust, and cost-effective ventilator designed from first principles to specifically handle the challenges faced in low to middle income economies. A recent article in the New York Times has clearly highlighted the severe shortage of ventilators in Africa, especially during the pandemic, stressing the need. To meet the demands of the low to middle income market, the OVSI ventilator was designed to be easy to manufacture, robust, safe, versatile, cost-effective, and to reduce the dependency on existing medical device supply chains. As with COVID-19, a versatile ventilator is required to treat the wide spectrum of COVID patient severities. Likewise, a ventilator in a rural clinic would have the same requirement to treat other respiratory ailments. The OVSI ventilator operates in CPAP, BiPAP, high-flow nasal oxygen, and invasive ventilation modes, with specification on performance just as good as each individual device. The ventilator is compressor-driven, thus requires no medical air, which makes it less dependent on resources and is portable. The OVSI ventilator is perfectly suited for use in low to middle income countries, as it is amongst the first to be developed for this exact purpose.
Thank you very much, Tashiv. That was absolutely excellent, and we'll come to some questions later. I'd like to turn to Shui now to give us a brief introduction on his project, please.
All right. Well, thank you, Karen. And it is an honor to receive this award. And so I represent the Oxford team, and I'm very lucky to working with brilliant young people, engineers. And we have Professor Wei Huang, and Dr. Jane Xu, Dr. Hong Chang, Dr. Hui Wang, Dr. Henry Jia, Mr. Bong Lim, and Mr. Richard Yu. So 8 of us. I'm the oldest. This is why I'm here. And we are very, very grateful to our employers. You see, employer is the University of Oxford, and particularly Department of Engineering Science and the Oxford Suzhou Center for Advanced Research, because actually they give us enormous support during the lockdown, enable us to do the work, you see. So what we have done? So we developed a rapid test on site, so anytime, anywhere, almost, and to test whether individual got a virus or not. So if I passing the airport or immigration, or you invite me to a party, and then how do I know I got a virus or not? So we just test at that moment whether the individual got a virus or not. Okay, so what we done? We developed this, the little test tube. It's very small, and so everything is in it. And then this will test virus, the COVID-19 virus, and from different samples. We could use nasal swabs, or swabs. It's horrible, painful. We did so many times on ourselves. And we could collect the saliva, but what we really want to do, promote, is to use mouthwash. Because actually the mouthwash protocol would be very easy, acceptable, very good for children, if your children back to school. So I give you a demonstration. Actually, you can see how easy it is. This is a test tube. So what I need, glass of water, I do a gargling, okay? I do a gargling. I use a cup, so you don't see what I eat at lunchtime. Now, and of course, this should be done 2 hours before any drink and the food. If you just had a tea and gin and tonic, then your results are not reliable. So then, what I really need to do is, this is how simple it is. I got the cup, I open this test tube, I use a little pipette, I take this. You can see this, you take actually the liquid, this is the sample, my mouthwash. I put it in to 1 drop, okay? So 1 drop, and that's what I need. This is a sample. Then the next thing I need is 65-degree heating source. 65-degree, okay, for 30 minutes. What I do in the home, I got a thermal flask, okay? So 2 parts of boiling water, 1 part of cold water, that's give you 65. We're engineers, 66 is fine, 65. So what I do, I drop this in it. If you are not sure, your home, you have a thermometer, you can measure. Then cover that up, leave it 30 minutes. Take it 30 minutes later, take it out, look at the color change. Now, fast forward 30 minutes. This is what it looks like. If it's a pink, that's negative. I don't have a virus. I can go to your party. If it's a yellow, you see this is a yellow is bad. You can see this turning to yellow. Then I go to isolation. So that's what we did, okay? You say, where's the engineering? The engineering is all in this little tube. So we have to control the biochemical reaction, not have false positive, false negative, only detect the virus, detect COVID-19 virus. The next aspect is how to scale it up. By the end of September, we will have a capacity to supply up to 1 million test kits per day. Okay, that's where the engineering. So the products got the CE marked. We can legally supply this now. We have a spin-off company in Oxford with a social venture spin-out company and to supply. And another thing is to make this really affordable, because we believe we have to test the people regularly and routinely, every week probably. If it's very expensive, we can't afford it. We'll bankrupt the country. That's it. Thank you.
Wow, thank you very much, Shrey. I think that was, I wasn't expecting a demonstration. That was an absolute treat for all of us, and I hope everybody really enjoyed it. So I'm sure there'll be loads of questions on this, but we'll save those for a moment, and we'll go on to Lydia now, who's going to explain to us about sewers for COVID. Thank you, Lydia.
Hello. Hello, everyone. Thank you for inviting me, and thanks also the Royal Academy of Engineering for organizing this event and the awards. My name is Lydia Vamvakeridou-Lyroudia. I'm a senior researcher at the University of Exeter, the Center for Water Systems. And I represent a team. I represent a team of 5 people at the University of Exeter, namely Professor Dragan Savage, Professor Albert Chen, Dr. Mehdi Khoury, and Dr. Gareth Lewis, and me. We were the team that produced Sewers for COVID on behalf of the University of Exeter. But it's not just the University of Exeter. Sewers for COVID is an international collaboration that had other 4 partners, KWR, which is a big water research institute in the Netherlands, ERACAT, artificial intelligence institution research in Spain, and 2 Greek institutions, the National Technical University of Athens and the University of Thessaly. So it was a big team, 15 people, 5 of them from the University of Exeter. So how did it start, and what is Sewers for COVID? Sewers for COVID is a digital observatory, a decision support system that is an application that for the epidemic management cycle for preparedness, early warning, response, mitigation, and recovery. I don't have something spectacular to say because we've not, I didn't know that we could make a presentation. So I just had to introduce it verbally. What is it? We can trace the virus, COVID, the SARS virus, in sewers. We can take samples, we can analyze them in the lab, and we can find out whether the virus is present in sewers. Now, sewers take the waste from large communities. You sample one location, and then you have information about the existence of the virus overall in the community at the, say, wastewater treatment plant. So the outcomes out of this sampling affect decisions for the whole community. Combine now the sampling in the sewers with any other type of modeling and artificial intelligence and complexity science modeling that you can do, combining socioeconomic data, epidemiological data, and also all kinds of information about from maps, from open source data of existence, other types of information in the community. And then you can build an information system that takes decisions or helps in the decision about this. So what we did with Sewers for COVID was to do this as a team with this, as I said, international team. There was a hackathon from the European community in April 2020 that promoted or asked for applications for this event. So this idea of combining the sampling from the sewers with artificial intelligence and making decision support systems, Sewers for COVID, we made an entry, we created a prototype, and we won. We won the first prize in this European event, the hackathon, in April 2020, that had over 20,000 entries from across the world. So that's Sewers for COVID.
Brilliant. Thank you so much. Thank you very much, Lydia. And I think it's interesting, isn't it, for all of us? I'm sure the audience has really enjoyed listening to a brief presentation of the idea that you had, how you developed it, and the resulting product, if you like. So I think I'll go back through you all now and tease out a few more details of the work and the ideas and so on, and give the audience time to think about any questions that they'd like to ask you. So I'll start off with you, Tashiv. You know, I suppose, you know, in the Western world, it's easy to, when a pandemic strikes, it's easy to be very selfish and think about ourselves, you know, and think about the immediate impact on ourselves and our immediate communities. But you chose to focus on low and middle income countries, and you chose to focus on those ones outside of the UK. So why was that? Why were you motivated to do that?
Okay, so the need for a ventilator tailored to low and middle income countries has been known for quite a while now. In 2018, childhood pneumonia alone has killed more than 160,000 children in West Africa. The shortage of ventilators in Africa is due to their high cost, their unsuitable design for operation in harsh environments, and the little local maintenance and support expertise. Normally, the development of a novel medical device would take many years of development and certification, would need a wide set of expertise which would not usually meet a strong manufacturing base and a very large financial investment. These are the main reasons why there has previously not been a ventilator developed to the needs of low and middle income countries. With the arrival of the news of COVID-19 and the imminent threat of a global pandemic, the old rules of medical device development no longer applied, and there arrived an opportunity to develop the novel ventilator that was so greatly needed by the low to middle income world. Furthermore, in countries with very weak social welfare systems, formal education of children can only occur if there is a strong breadwinner in the family. Should the breadwinner be affected or removed from the family, for example, by illness, the youth must compensate for this deficit. This greatly reduces the socio-economic development of the country, with this effect carrying over to the next generation. It is vitally important that we keep the breadwinners in the low and middle income economies in good health to ensure the success of the next generation. Lastly, I am a South African national and have also spent 2 years in Kenya developing the first locally manufactured renewable fueled fluidized bed power plant in East Africa. So I'm particularly fond of developing new technologies that can be locally manufactured in Africa.
All right, okay, yeah, I can see that there's always a hook, isn't there? There's always a personal interest. So I know that the Open System Ventilator Initiative has been working in South Africa to deliver ventilators. So why did they choose this initiative, and what are the plans for this initiative, you know, going forward in South Africa?
Okay, so the main reason that the OVSI ventilator has gained such rapid success is because we chose to develop a ventilator architecture to feel, to behave, and have the feature and safety set of a proper ventilator, not a rapidly manufactured ventilator. This ventilator, after all, was meant to be used for and after the pandemic. The ventilator project, the National Ventilator Project in South Africa, a ventilator program similar to the Ventilator Challenge in the UK, has selected the OVSI ventilator as a top priority submission. The appeal of the OVSI is the wide range of operating modes, the non-requirement of medical air, the cost effectiveness, the functional simplicity, and most importantly, a high local manufactured content. The OVSI is more than 70% locally manufactured in South Africa. So far, we have developed about 20 prototypes, which are currently undergoing tests on usability, performance, and compliance at various laboratories, academic facilities, and certification bodies. Once this is complete, we will formally submit our application to the South African Health Regulatory Body SAHPRA for certification and license to manufacture. Our manufacturing partner, DeFi Appliances, has already converted one of their production lines and is gearing for mass production. This ventilator, we hope, marks the beginning of a new medical device industry in Southern Africa. This will bring new investment, new technological skills, new employment, and most importantly, will save lives. A very exciting prospect indeed. For the future of the OVSI, we'd like to join forces with philanthropic organizations, health departments, NGOs, and major industries that would purchase and support these ventilators for communities that need them the most. With the scales of manufacturing, the more units we produce, the cheaper it becomes. We have more parts and wider support will be available.
Yeah, thank you, Tashiv. And you mentioned there, Tashiv, about local manufacture, which I guess is really important, you know, because that provides jobs as well. But have you had any challenges in terms of local manufacture on a large scale? And, you know, is there any particular challenge in the lower middle income countries?
So there's two main challenges that were clearly shown during the pandemic. Firstly, there was the global price war for limited supply goods, which usually favor wealthier countries, the ones that pay the higher price. And secondly, the reduction in global delivery bandwidth to middle and low income countries in order to prioritize supply to the countries that could pay more. Both these challenges actually was an opportunity, because what we've done is it allowed us to develop completely new valves, new flow meters, and other ventilator components using materials and methods from other industries, such that we were not dependent on the limited global supply chain.
Yeah, I see. Okay. And have you come across any, there's a question in the chat which is pertinent to this. Have you come across any problems in navigating regulatory and approval processes in any of the countries?
So initially there was a lot of confusion as to how to address regulatory approval, because you know, this was the first time in many generations that we've encountered this. However, I did feel that there is great need to get devices out to people, and the African regulatory bodies were very open to actually allowing devices coming to the market. It's quite pleasing.
Yeah, that is pleasing to hear. Okay, Tashiv, well, I'll leave you for now. And I think some more questions may come in from the audience for, you know, around the ventilator work. But I'd now like to turn to Shui, and I've got so many questions for you, and I can see already some coming in. But for me, first of all, I mean, I'm hearing a lot about all sorts of different types of tests. You know, Cardiff University is doing some testing, and, you know, so-and-so university is doing testing, and Oxford University, and, you know, so there's lots of different kinds of tests, virus tests, antibody tests. So can you explain to us all what sort of test yours is, and what's perhaps new or special about it, and what makes the big difference? I think I know, but, you know, I'd like you to expand on that. All
right. Well, thank you, Karen. Now, basically, there are mainly two types of tests. So one is test the antibody, one is test the virus, whether people get a virus or not. So if people get infected before, even recovered, and then they got antibody. So if you want to looking at whether people should go back to work, if already get antibody, that's relatively safer. So you have offer some kind of immunodefense. And ours is test actually the individual at that moment get a virus or not, and whether still infectious or not. So the application ours is mainly targeted like in the airport, like a school reopening, university reopening, back to work, sports events, parties. This is actually when people get in, whether you allow this individual get in or not. So that is actually our test. So we are not unique, and then there's a lot of this test. The standard one is RT-PCR. That's why you see people driving through, take a sample, for example, then that sample will send back to the lab. So to do RT-PCR, you need a dedicated lab and a machine and the operators. So then the turnaround time, because you need the transport, and then you need the queuing to do the test. So today's news, probably many watch BBC News today, they said that now the waiting time greatly reduced. You can get the results back in 1 day. And they used to be sometimes 2 weeks. So then the test is absolutely useless anymore then. So actually ours, we can get results from test to results in 40 minutes. And then we don't need dedicated equipment. So actually you can test in school, you can test in university. So that is actually the point of care where you need it. That is actually our, I think, differentiate ourselves from the rest. And the other thing is actually basically our products get approval also use the swabs, but the swabs is really painful and annoying. And then you can't put this into small children, for example, school kids. So then this is why we developed this mouthwash protocol. And that's proved actually in the lab, we all test is actually far more reliable and consistent.
Yeah, that's great. And I think, you know, it's fascinating. The 40 minutes is really critical, isn't it? And I can imagine, I mean, I'm thinking of the logistics now, and I'm thinking of my party that you've invited everybody to. And I'm thinking of, you know, lining people up down the street and waiting for 40 minutes before they come in. And that's doable. You know, I can imagine myself working out a logistical way to do that. What about larger events? What about things like, and we've got a question from somebody, from Gianluca Sardi. So do you think your excellent test can be used even in football grounds in order to check if supporters entering the stadium are positive? So you talked about sporting events, and if you think about, you know, say a popular Premier League football event, perhaps 60,000 supporters, how would it work?
Well, I think you see, this is the one important part. Actually, what I did a demonstration that clearly show you actually can test at home, right? But at the moment, the government, both in the UK and the USA, or China, for example, they don't promote home testing, DIY testing. You can take a sample and send it to the lab. The reason is that because we want to test and trace. And then if you test positive, you don't tell anybody, so people don't know. But I think that this DIY test at home will become a reality sooner or later. In that case, for example, you can test, for example, before you go to the events. And then we have to trust people. The other thing is that you see, you could actually allow people, because this is actually when we started this, why set 30 minutes as the time limit to do the test? It's just because when we came back from China, when China in high alert in January, we passing from through Heathrow, there's no question asked. So I just timing, get off the plane and get off the immigration. The quickest you get the A terminal gate is take you about 30 minutes. So if we can get off the plane, take a sample, do a test. When you get off the immigration, you already get receive a notification you are clear or not. So that's actually, I think it's all doable, but then this is actually, but it's not us to do it, it's a service provider to do it.
Yeah, exactly. I see. So I'm seeing some questions coming in for you, and I think I'd like to pick those up, you know, quickly now rather than sort of waiting till we get past, we talk to Lydia. So I've got a question here about thanking you for such a great development. So asking, what is the sensitivity? It's from Vamvakeridou-Lyroudia. What is the sensitivity of your test method to the number of viruses per unit volume of liquid? Are you able to answer that?
Yeah, I could. It's quite very technical, but then it probably does not mean a lot to many other people. But then the sensitivity ours is actually, because we do directly test, is 800 copies per mil. So that's basically equivalent to the standard PCR test. So this is actually we claim, so it's almost identical to the PCR test. Yeah.
I see. And I'm just going to ask you another of my questions here while I look at the other questions. So you developed a test kit, which is really smart, you know, and you said that the innovation and the engineering was in your test kit. So did you experience any challenges and obstacles in that development? Because it's been really rapid, hasn't it?
Yes. Well, we had 2 months advantage than most other groups probably in the UK because we started in China. And because I run Oxford Pseudo Center for Advanced Research, is Oxford University Center there. And so then the challenge actually we have is those we couldn't control. And one of the main issue is clinical validation. So because we got the results, we said that this is plan A, plan B, plan C. We did all the lab tests. But then there was no samples in the UK at that time, before end of the March, there's no, you see. And then we couldn't send it back to China because China is in lockdown.
Yeah.
And then so that's actually delayed a lot of time. And then is I think that was one of the major challenges we have. Another one is about a large scale manufacture, because most of the biopharmaceutical process plants in this country all went to the vaccine manufacturer, and almost there's no spare capacity. So I think that is actually, it took us quite a long time to get secured the manufacturer, contract manufacturer.
Yeah, and so you've got that manufacturing contract now, and you're going to manufacture on a huge scale from what it sounds like. So are there any challenges to getting that available broadly and quickly, you know, perhaps before the university's return? I'm thinking very selfishly now.
Now, because we got the test, we can supply the test, but then so at the moment this is exactly the challenge. Another challenge, we need a service provider, because we are not the one go to all the universities, go to schools. And so we are looking for service provider who actually perform the test. And it's a very simple, 20 minutes training, and the accessories, equipment is very cheap, very easy to set up. But so we are in various service providers.
Right, okay, so good advert here. And so to those hundreds of people out there, if you know of a service provider, please put them in touch with Shrey. I think we should go on to, we've got some more questions coming in. I'm going to leave those for now, and I'm going to go on to Lydia now. So Lydia, thank you very much for your presentation. And you know, I had heard about the sewage testing before, and it seems so logistically smart, doesn't it? Do a mass test and then home in. You know, it's the way I do non-destructive testing, actually. So you know, the principle is really smart. So you know, do you think that sewage monitoring can help us with the sort of testing that swabs can't? You know, how is this working logistically?
Actually, it's two different things. They complement each other. With the shearers, you have three advantages. The first is a window of days of time, because the virus can be detected in the shearers days before the person has symptoms. This has been proven in the Netherlands. As I said, my second affiliation is KWR, and they have been doing this since February. It was proven. So it can be detected earlier. You can have an early warning that a whole community has started presenting symptoms. The second is the number of people. You just do one test, and then you have information about the whole community. For instance, the whole drainer, or the whole sewer area that is draining in one wastewater treatment plant. If you take one sample there, you know about the whole community. So that's the second advantage. But also it's objective, because even if you have compulsory or voluntary testing of individuals, there are some individuals that, because of, say, socioeconomic conditions, will not go get tested. So the samples we get are more or less biased according to the socioeconomic background. With the sewers, there's no bias at all. It's the whole community, a whole area, if we take it in areas. And of course, we're talking about quite different cost in scale. So we're talking about currently, testing an individual costs something between 70 to 150 euros, depending on the country and the technology. Testing the whole community, it costs today with this technology about 220 to 250 euros, but it's for the whole community. So you can do it day after day. We cannot compete on speed. We cannot make an assumption for 40 minutes, although it doesn't take any more one day. It's down to 12 hours. And with KWR and other people that are working on portable semi-automatic samplers, it can go down to 6 hours. But there's no need for it. I mean, for the operation of the whole system, for the operators of the end users, which are the utilities, having the information once a day is more than enough. They have the early warning that something is happening in the community.
Yeah, okay, I appreciate that, yeah. And then the other thing I was thinking of is that, you know, presumably you're relying on sewer monitoring. That's in the name of the title of the project. So what about countries where we don't have the infrastructure of sewers, such as, you know, developing countries, or perhaps, you know, places where we're really worried about the pandemic, you know, the pandemic breaking out, such as in refugee camps. So is there anything that your technique can be used to help, you know, is there any way that your technique can be used to help in those situations without actual sewer monitoring facilities?
Precisely this, it's very suitable for this, because it doesn't need, I mean, we say we sample the sewers or we sample the wastewater treatment plant, but it's not the existence of the plants that plays a role. It's just a place where we have the human waste, so even latrines that exist in plants in refugee camps. We can take a sample. So it's a method and a technology and the assumptions which is especially useful for countries that don't have the infrastructure and places where are extremely concerned about outbreaks that may quickly go out of control.
I see. Thank you very much, Lydia, for explaining that. That's really, really helpful. Now, I first heard of sewage monitoring during the COVID crisis, but I wondered whether it had ever been used in the past for any sort of health monitoring, and how challenging would it be to adapt it for other things, such as emerging diseases or varieties of SARS and so on?
Well, the question has two parts. The first part is about the past. It's not something new. In the 60s and the 50s, people had started testing the sewers for polio. And that's where it all started. So over the years, there was a lot of development in this. And recently in the years, I mean, in the last, say, 10 years, there has been a detection of emerging substances and drugs and such things, small quantities in sewers. Actually, that's how it started, because KWR and was testing the sewers for drugs. So the technology was there, and that's how we started testing for the virus, this virus. So that's a long story. It's easy to monitor for other things because the technology is there. For instance, you can monitor biomarkers, which shows whether the whole community is, for instance, using more, I don't know, even say, drugs because of the lockdown, additional information. For instance, this has been also being collected and assessed because they have found in other countries and also in the UK that the presence, for instance, of detergents and also because of where we wash our hands, or the presence of, say, alcohol has increased in the sewers during the lockdown. And so it can be used for other diseases, for other viruses, for outbreaks that have to do with, I don't know, hepatitis or any kind of disease. So we would like to see that we called it sewers for COVID, but in reality is a pandemics observatory, sewer surveillance for pandemics.
Yeah, brilliant. Thank you. Yeah, that's really, really fascinating, Lydia. Thank you. Right, I'm going to go. We've got about 20 minutes left. So I'm going to go back to the audience questions. I'm going to encourage the audience to put in questions if you want to. We had a very early on one, which I'd like to ask Shui now. I'm not sure whether you want to answer this or whether it's IP protected, but we have a question from João Victor de Mella, who says, what is the chemical reaction that happened in the tube that one gets yellow and the other gets rosé?
Right. No, it's fine. You see, that is not a secret. We have to disclose all this when we apply for regulatory approval. And is actually the reaction unit is so-called RT-LAMP, reverse transcription loop-mediated isothermal amplification. So it's a one way to amplify RNA. So basically the virus, this COVID-19 SARS-CoV-2 is an RNA virus. So we have to pick up that virus, convert it to the DNA, that's so-called reverse transcription. And then the DNA, we can amplify it. You make, if you got that RNA, that section of RNA amplify a lot to the stage we can detect. So PCR is doing polymerize the chain reaction to amplify the DNA, and we use LAMP, and LAMP is faster, but it's very difficult to control. The problem with LAMP is not new. It's actually invented 20 years ago by Japanese scientists, but then you see it's not widely used because it's difficult to control the reaction. So you end up a lot of false positive. So, and then our contribution is to control this, first to get the right target. Second thing is to control this biochemical enzyme reaction, basically. So in the tube, we have enzymes, several different enzymes to do the different steps of the reaction. And then we have this so-called primers to identify this virus RNA. And then the pH change, this actually, when they actually amplify a lot of DNA, they actually, each DNA, this got a phosphate group come out. Basically, the pH will drop, become acidic. So then that pink color is simply a pH indicator. When higher pH is pink, when a lot of pH drop, they become yellow. So it's very simple.
Okay, okay. And does you talked about false positives, but I guess we'd be more worried about false negatives, wouldn't we? So this method protects against false negatives.
Yes, yes. Basically, it's just like, this is why one of the patent, we filed a couple of patents. One of them is we introduce a molecular switch. We only target this reaction. And then you see, this is like, by design, you eliminate the false positive and the false negative.
Yeah, and as engineers, I guess we always look for enhancements to any system. And I've got a question here from Jolyon Kaplan, which is an enhancement. Have you thought of a way to tell when the excellent 40-minute test has been taken so that people don't use an old test and pass it off as a new test? So can you have time markers on it?
You mean time marks of when we stop the reaction?
Yeah.
Yeah, well, actually, because we opted for the colorimetric change color, this is a very simple. And then actually for people really get a lot of virus, the color will change in 15 minutes. You see actually much earlier, you can see the color change.
Yeah, but the question is, if somebody takes the test, say a week ago, but then passes off a negative, test as a positive, when they would have tested positive, if you see what I mean, so to prevent people using old samples for proof of lack of COVID, I guess.
Well, I think that's, you see, that all this got problems. Even actually, you see the government collection from the home, how do you know they actually gave you the genuine sample? And then there's actually a recent paper just come out to test different sampling method, how accurate it is. The worst one gave accuracy of 30% accuracy. And because it's a different sampling method. You see, this is actually not intentionally try to hide the results. It's just a normal one, and then you still get that.
Yeah.
I think that's all this, we face all the same issue.
We do, yeah, we do. It's something to be addressed, though, isn't it, when we think about how to apply these tests and the processes. I'd like to ask a more general question now, perhaps to either Tashiv or Lydia or both of you, and it's from the audience. It's a question from Mark Jeffries, who asks, what do you think are the key lessons learned from reacting so fast to the challenge that could be applied to other areas of collaborative R&D? Lydia, perhaps?
Well, I think the main thing the main lesson we learned and the main experience we had was that the breadth and the interdisciplinary collaboration we had. Someone said it before that fighting pandemics is not one person or one team or one expertise. In order to act fast and effectively, we need to collaborate. Not just in the UK, we need to collaborate with other countries. It's something that not just sharing resources, but also sharing ideas and also sharing expertise. And I think that's the main lesson, that it's a global challenge that needs global responses and global collaboration.
Yeah, and picking up on that, Lydia, I think, you know, one interesting thought I had was that, you know, has it been difficult working globally during a pandemic? So closed borders and remote working, you know, has your team adapted to that very well, or have there been specific problems about not being able to meet face to face?
Well, we had to, didn't we? I mean, there was the lab, that was physical, that was in one place, it couldn't go. But the data from the lab, the rest of us were working, you know, remotely and for days, because we had to. Actually, it was a hackathon, so it took us about 60 hours from start to finish to submit the entry and the application and for the board. So it was, we worked remotely. It was fun in the end, I would say, as a team working remotely, because we had also our private chats. We had a lot of jokes, apart from, lack of sleep for days. But that was the fun part of it. It also gave us the opportunity to explore further ways of collaboration remotely. And now we are, as a remote, wider team, participating in a wide project that Sentinel on serious surveillance, which is being led by the Joint Research Council of Europe. We are participating as Exeter there, and also with a lot of other institutions and over 90 utilities all over the world that are collecting the samples and collecting also and sharing the information. So it was a big lesson on sharing resources, information, expertise, and ideas.
Right, yeah, thank you, Lydia. And yeah, I think Tashiv, you know, have you got any thoughts on that, or whether there's any key lessons learned? And perhaps you could pick up another question from the audience, which is from Antonio. How does the COVID pandemic and your contribution going to change your future research direction?
So just to pick up on what Lydia has said, because I think it's quite important. I'll answer Antonio's question just after. I think there's definitely certain merits to the digital meeting place. You know, in short notice, you can have a lot of stakeholders join a meeting and be very productive. But the main problem is that you require stable internet access. That's something we take for granted in the UK, but that is a luxury in some countries. You know, the collaborative development of physical devices is quite difficult because it's not digital, and delivery services is essential, but it's quite slow. And the worst aspect is if once you ship your equipment, you realize you just forgot a small tool that's really vital. You know, it's quite problematic. It's also lockdown rules can be very different in different countries, and so are the changes. You know, in a matter of a week, what you would have assumed was going to be the norm has changed completely. And this can make planning really tricky, especially if you have cross-border, interaction. But, you know, I'd like to take this moment in thanking everybody who's really risked themselves by exposing themselves to work during these trying times to help others. And, you know, I'm really grateful that has occurred. But to answer Antonio's question, I think that in the case of the ventilator, we're not just creating a medical device for the pandemic. We're also creating something that can be used afterwards, especially in rural areas. In South Africa, there's a possibility of creating a new medical device industry. And this is important because it doesn't require the great expense and lengthy negotiations of importing expensive foreign skills. You know, this I think will really serve a great inspiration to the up and coming generation. And more widely, it's, as Lydia said, it's shown us how easy it is to share ideas, how easy it is to solve problems collaboratively, especially with people you would never ordinarily meet. Wherever in the world you are, getting expert help is just a Zoom call away.
Yeah, exactly. It's very, very inspirational and invigorating to hear your response there and your enthusiasm. Thank you. I've just noticed something come in as well for you, Tashiv. I don't know, can you see these questions and answers? You can actually. So well done, Tashiv. You've made a noble vision and great product. How do you plan to prevent huge industries from capitalizing on your production and supply purely financial gain? So how are you going to protect yourself from these hawks who are going to steal your ideas? And how are you going to protect yourself? And how are you going to ensure people on the ground have access to the much needed ventilation?
So I think the pandemic has really brought out the humanitarian spirit in a lot of us. And yes, we have encountered in the project quite a few people trying to capitalize on financial benefits. But the program is open source. It's quite large now. And I think that if it's definitely being noticed in Southern Africa. And I think once the clinicians start accepting the ventilator, the name would become bigger than an individual. And I think that's what we're really hoping that is going to happen in this case.
Right, okay, thank you. Thank you very much. Now there's a question from Suzanne Bucknell for Shui, if this has appeared in any journals and if you have a reference. I don't know whether you have any journal references yet, whether you've had time to publish this.
No, yes, we have. We have 2 papers already all published, and one in general microbial biotechnology, one in biodesign and manufacture. We actually have another manuscript is under review. And so that's why you see we don't make a lot of publicities, but we have to go through the rigid scrutiny of peer reviews. So that's, yeah, we have, and then I'm quite happy you see it's in public domain anyway, we have papers.
Yeah.
Now, Chair, can I steal you 10 seconds?
Absolutely, go ahead.
I'm very pleased to tell you I'm actually negative. This is a test I just done, okay? I just take it. This is not the one here. This is the one. This is the one just to come out. Yeah.
So Shrey, thank you. You can come to my party.
I can come to your party.
Yes, you can. Brilliant. Okay. Somebody's asked a question: how critical is the water temperature of 65 degrees? I would imagine that's pretty critical. What's the tolerance on that, Shrey?
At least 2 degrees up or down. So okay. 63, 67, all fine.
Yeah, okay. And there's a general question from Louise Mbua. What incentive would the Academy and the government provide to encourage young people and training providers to take up engineering? I think that's a difficult one for me to answer, actually. My own view, and I'll go back to what Jim and I were saying at the beginning, is that the Academy, This Is Engineering campaign, we all know as engineers that engineering is a fantastic career. So I think it's incumbent on all of us as a body of engineers to encourage young people to take up engineering. I think that there are various schemes, bursaries and so on to help people study, and we work passionately to try and get more of those. But the incentive for me, when I chose engineering, was the ability to make a difference. And I think if we carry on convincing young people that engineers make a difference, we will get lots of people, following in our footsteps. So I would urge you all to speak out about what a wonderful career it is and how it makes a difference to the world. Right, okay then. So just, I think we're sort of summing up now, but I think interesting to ask the 3 of you, and I'll come to you in the order that we went. So Tashiv, Shree, and then Lydia. Do you want to have a couple of about 30 seconds each to sum up perhaps what learning you're planning on taking forward following your experience with these projects?
So I think one thing that's become really clear is that the world has truly become a global village. When I was younger, I've always heard people say this, but it now really feels like that's a reality. Sharing ideas, technology, and solutions are just as easy as sharing cat videos. With the new age of digital collaboration, we have a much better chance to make the world a better place for all, I think.
Thank you, that's really inspirational. Lydia, any final thoughts?
Well, I think we are never going to get, it was a very new experience dealing with a pandemic, and we're never going to get rid of it. And even if you get rid of it, there will be a second or the third or another wave coming. So what I learned from all those things is that we need to be ready for the second and the third and the unknown wave. And I think that serious COVID can make a difference in this, in detecting future waves of pandemics, which we don't even know what they are now.
Sure. And Shrey, any final thoughts for us around, what have you enjoyed most and what are you planning on taking forward?
I just feel actually, I feel very lucky. I'm an engineer. Actually, you see, engineering, actually, we can do something in this pandemic, because I'm sure there's a lot of other engineers, colleagues also want to contribute. I have been very lucky to have this brilliant colleagues and students and then working with me. And also we have the facility and also the environment that can support this project. So I think we actually take a great job of satisfaction as an engineer actually to do something in this pandemic.
Yeah, absolutely. The feeling of being able to do something is really important, isn't it? There's nothing worse than helplessness. And I think the helplessness at the start of the pandemic has been replaced by optimism. And certainly if we're people who are part of that optimism, it's really rewarding, isn't it? Yeah. So thank you for that thoughts. Right, okay, I'm gonna sum up now. I thank you all for your time. I mean, thanks to the hundreds of people who have been listening to us all, but thanks especially to the panel members, both the winners and the panel members for taking your time this afternoon. Further information on all of the winners can be found on the Academy's website, along with all of the previous Innovation in a Crisis webinars. I hope you've enjoyed today's event as much as I have. I hope that you feel incredibly proud, as we all are, of the engineering response to deliver meaningful results through the crisis. One thought I would like to leave with you perhaps is that if you've been inspired by what you've heard, throughout this series, and if you feel able to, can you please remember that the Royal Academy of Engineering, is a charity and is able to take charitable donations. So, we would really welcome, if you're able to, your support through a donation to the Royal Academy to enable us to go on and carry on doing, all the work that we do to encourage and to support engineers. Donations ensure that we can continue to make our work available to as broad an audience as possible and to also increase the engineering impact in society. And if you feel as passionately as I do about engineering, then perhaps you would think about that. So there'll be a link on the slide at the end and a follow-up email, which will also ask you to provide feedback on the event. I'm going to close the event now. So again, thank you all our speakers and delegates. We're going to end with a slide with the winners' names and their projects, but also we're going to replay the beautiful video at the beginning, which I think the gremlins got into with the sound. So we're going to repeat that video. So thank you very much and goodbye, and stay safe, everybody. Goodbye.
We have been facing the biggest public health crisis of our time. As we thank the frontline workers helping us to fight COVID-19, we also want to acknowledge the teams behind the scenes, whose commitment and creativity are solving challenges we've never faced before. The engineers who designed, tested and manufactured thousands of ventilators and breathing aids, constructed and equipped the Nightingale hospitals, made sure critically ill patients had enough oxygen to keep them alive. From universities and businesses across the UK and around the world, they've made new alliances and found new ways of working to make sure doctors and nurses could work safely, to develop new tests and vaccines, finding ways to save lives in developing nations and to keep us all safe as we keep the country moving. To recognise their contribution in the fight against coronavirus, the Royal Academy of Engineering has created the President's Special Awards for Pandemic Service, presented to 19 teams who have delivered the extraordinary during the crisis. Find out more about the winners on the Academy's website and join us in celebrating their ingenuity, dedication and hard work.